Hello family, my name is Des and we are starting with we are continuing with combined science. I like to start with a lot of energy so that you have also some energy to go by, grab some coffee, do something, get ready for the class today. So we are starting our combined science class and we are still doing our physics section and we are still working on the topic motion. So working on the topic motion in combined science. So like I always say, school is supposed to be fun. You should have some fun. So make sure you have some fun. Okay, let's go. So first thing that we want to do is we want to define speed and calculate average speed. So what is speed? Basically, speed is just the change of distance with time, right? So if I drive for using my let me just get my laser pointer, right? If I use this Maserati, right, this is my favorite car. If I drive using a Maserati, because it's a fast car, right, if I'm speeding up, it means I'll take a shorter time to cover a large distance. But if I'm using another car that's not as fast, I will take a longer time to cover the same distance, which means the Maserati is faster. The Maserati can travel at a higher speed. So speed is a change of distance with time. It is measured in kilometers per hour or meters per second. Average speed is calculated by dividing the total distance traveled by the time taken. So the reason why we calculate average speed, because we're saying that's the speed for the whole journey, because as you go along the journey, as you're moving from point A to point B, sometimes you're going to get into congestion, sometimes you're going to get into all sorts of things, and you have to reduce speed, and sometimes you get into a very wide main road, a highway, and you have to speed up and things like that. So the speed will be changing. But when we are asked to calculate average speed for the journey, we're just saying the total distance for that journey or part of that journey that we want to calculate over the time taken. So that's why we use the word average speed. We're saying what is the average speed? On average, what is the speed that this car was moving in for the whole journey? So speed is equal to distance over time taken. If you memorize this triangle, you would have memorized all three formulas. So if you say speed is equal to distance over time, it also means that time is equal to distance over speed. It also means distance is equal to speed times time. So if you just memorize this triangle, you will be set. So sometimes you have to change units. So for example, in this question, it says a boy takes 1 hour to travel from his home to the cinema, a distance of 10 kilometers. Calculate his average speed in meters per second. So what is the average speed of this boy in meters per second? So average speed is equal to distance over time. So we want to change this 10 kilometers into what? Into meters. 1 meter is what? 1,000. 1 kilometer is 1,000 meters. So if you want to get 10 kilometers in meters, you say 10 times 1,000. You get 10,000 meters. Then if you want to change hours into seconds, you first change the hours into minutes. So 1 hour is how many minutes? It's 60 minutes. So you say 1 times 60, you get 60, right? 60 minutes. Then 1 minute is 60 seconds. So how many minutes, how many seconds are in 60 seconds? You multiply by another 60. That's how you get our what? 3,600. So if you divide this, you get 2.8 meters per second. That's our speed. So that we don't waste a lot of time, I'll allow you to take a pause right now if you want to really digest this, and then you can resume once you are done. Now, suppose a bus travels the first 240 kilometers at a speed of 80 kilometers per hour. It then covers the next 360 kilometers at a speed of 90 kilometers per hour. I made a mistake here, so it was supposed to say calculate the time taken to cover the first 240 kilometers per hour and the time taken to cover the second 260 kilometers. Time taken to cover the first 240 kilometers, this is distance, and the time taken to cover the second distance. So can you try and calculate using that triangle formula that we've just discussed? And I want you to try and create and calculate the time taken for this part of the journey and the time taken for this part of the journey. And we'll see you. So pause the video and then you can play once you're done and use the answers. Okay, these are the answers. So for the first 240 kilometers, remember we said speed is equal to distance over time. But if you're using that triangle, remember that triangle we did time is equal to distance over speed. So you won't even need to go all through this working, right? You just say time is equal to distance over time is equal to distance over speed, which is 240 over 8, you get 3 hours. Then for the second journey is 360 over 90, you get 4 hours. So if you want to sink this to sink in, just take a pause, go over it, and then when you're done, you move on to the next slide or the next part of the video. You just it. Then suppose the truck travels 60 kilometers in the first 1 hour, and then it travels 80 kilometers in the second 1 hour. What is the average speed for the whole journey? What is the average speed? That's what they are saying of the truck, right? So what you do to find the average speed, you say 60 plus 80, you get 140. That's the total distance that has been covered, right? Total time is 1 hour plus 1 hour, which is 2 hours. So total distance traveled is 140. Total time traveled is 2 hours, so it's 140 over 2. You get 70 kilometers per hour. That's the average speed. I hope we are together right here. Yeah, this truck must have been speeding. Now we want to learn how to plot and interpret a distance time graph. So the first question that we want to do or the first thing that we want to work on is, how do we plot a distance time graph? How do we do that? So we are given a distance time graph like this one. So this side is distance, this one is time, right? So we are told that a bus travels for 4 hours from Wakanda City to Mboma town, which is 50 kilometers away. Plot the journey on a graph. So so how many hours does it travel? 4 hours. What is the distance that it covers? 50 kilometers, right? So let me get my pen. It travels for 4 hours, a distance of 50. So I come here, this is 4, this is what? 50. So I come here and I put my plotting here, right? And then I draw a line. Oh, this is the wrong line. My line is supposed to come on like this, up to this point, right? So don't mind this one. This one is the correct line. So not very correct, guys. Come on. Like, I'm using my free hand, but you get the idea, right? I'll show you the correct line in the next slide. So this is like the perfect line, right? That we were waiting for, right? This is a perfect line. So this is a distance time graph. This is distance, this is time. So let's look at gradient. What is gradient? Gradient is the steepness or gentleness of a slope. So this hill or this mountain has a very steep slope, right? If the mountain was more flat, it means the slope would be what? Less steep, right? So if we can calculate the gradient of this line, so a line like this would be more steep than this one, right? So if you can calculate the gradient of the line, you find the average speed of the journey. So the gradient of a distance time graph gives you the speed of the journey, the average speed. So the distance was 50, the time was 4. So I want you to calculate on the side using the normal formula we used before to calculate the speed. And then I will also use the gradient. I will calculate the gradient together and see if we get the same answer. So calculate the distance, which is 50 over 4, and just put it on a piece of paper, and then we'll come back to it. So when we're using gradient, when you're calculating the gradient of a line, right? The first thing is we choose 2 points on the line. So I'm going to look for my pen. We choose 2 points on the line. So the first point that we may want to choose, I usually want to choose points that are exact, right? So for example, 0, 0 is exact. This point, I'm not sure if it's a 7 or if it's an 8. Why? Because there is no graduate here, right? So I like to use points like this. So just choose any 2 points that are exact on my graph. So this point, and then I also choose this one is exact because it's 4 and 50, right? So I've chosen another point, this one, right? Those are the 2 points that I've chosen, right? And then so this point, right, it represents the first coordinates that I'm going to use. So this point 0 is going to be what? X1, and then this other point is the y part is equal to the other 0. This is x1, right? This is y1. Then here the x-axis is 4, right? So this would be what? x1, x2, sorry, and y2 is 50, right? That's how you have the coordinates, right? So we know the coordinates here is 0, 0, right? Which is 0, 0, x is 0, y is 0. Then for this one, this point here, the second point, let me go back. So we know the coordinates at this point is what? 0 is 0, for x is 0, y is 0. So the coordinates here is 0, 0. Then for this point, we know the coordinates is what? 4 and 50, so it's 450. So to calculate the gradient, you say y2 minus y1 over x2 minus x1. So y2 is 50. So this point that is further away from the 0 is the one you say x2, y2. This one closer to the 0 or at the 0 is y1, x1. So y2 is 50, y1 is 0, x2 is 4, x1 is 0. So y2 minus y1 is 50 minus 0, x2 minus x1 is 4 minus 0, so you get 12.5 kilometers per hour. That's supposed to be your answer. I hope you got this answer correct. If this answer is exactly the same way, this answer must be exactly what you got when you just said 50 divided by 4 using the normal method. So this is how you find the speed, the average speed on a distance time graph. You calculate the gradient of the what? Of that line. Now, we want to work on how to plot a distance time graph. Now we want to make this more complicated, right? A bus travels 1 hour from Wakanda City to Natalie Town, which is 50 kilometers away. So this is the first part that we are being told, that this bus travels for 1 hour. So 1 hour from here to here is 1 hour, right? And it covers 50 kilometers, right? So we want to put a point somewhere here. And then we are told that it stops for an hour at Natalie Town and goes back to Wakanda. So it stops for an hour. So from here to here, it was stopping. From here to here, the bus was stopping. So it's not, the distance is not going to change because it was at the same place. And then we are told that the bus goes back to Wakanda City. The journey takes 1 hour. So from here, it goes back to Wakanda City. From here, this is Wakanda City, right? At 0 distance away. It goes 50, it rests for an hour. It goes back to Wakanda City. So now it's going back to 0 distance where it started from. Well, the distance is 0, right? And it covers that distance in 1 hour. So this is going to be the other point. So how you plot the graph is you do this. My lines are not straight, but it's supposed to be straight line. And then you come back here. And then you come back here. So at this point, the bus is traveling at a constant speed because the gradient, if you calculate this, you get average speed, right? So the average speed of the journey here, right? And then the bus is not moving, it's just stationary for 1 hour, and then it goes back to 0 or to Wakanda City in 1 hour on the other side of the graph. I'm sorry, I'm forgetting to put my laser pointer on, so let me just do that over again. So a bus goes from Wakanda City to Natalie Town for 1 hour, and Natalie Town is 50 kilometers away. So this is the 1 hour it travels, and then it's stationary for 1 hour at Natalie City. It doesn't move, it's just parked, and then from there it goes back to Natalie Town for another 1 hour. So this is how the graph will look like. So this is how you plot a distance and how you interpret it. I hope it makes sense. So in our next lesson, we're going to start doing velocity time graphs, and we're going to look at velocity time graphs and how all of these things work out. So I hope you understood everything we've done in the previous lesson, and I hope everything is good and you're ready. So until then, watch this video over again, and then before you jump into the next one. Okay. Peace.